Okay, so today we're going to look at what we have in regards to fractional exponents. Yes, fractional exponents. And we know exponents tell us how many times something has been used as a factor. So, for example, we know that if we have a squared, that means a times a. What does it mean if you have a to a half? So how can you use something half a time? So now we're going to look at what that means, though, then to have something that is in that fractional form. So we've got a little bit of something to work with. As a result, if you have something rewritten in a fractional exponent form, I can rewrite it in radical form. It really means that we're going to take a, instead of being a base, it's going to become a radicand. And the denominator of the fraction is going to become the index of your radicand, of your radical, and the numerator value is going to become the exponent. Now, the exponent can actually go in one of two places. One, it could go underneath the radical and be attached to the radicand itself, or the other option is, again, n still is going to be in this place, the index, it could be in a set of parentheses outside. Now we're going to look at two cases in regards to when should I keep it with the exponent underneath the radical versus when do I really want the exponent outside the radical. Sometimes it's more helpful inside, sometimes it's going to be more helpful outside. Alright, so a couple of things that you need to be able to do is you need to be able to rewrite from one form to the other. So given something such as the cube root of 5 squared, I want you to be able to rewrite this using a rational exponent. So again, the radicand itself now is going to become the base, and then you have to make the decision, what are you going to do with that exponent and the index? You want to turn them into an exponent, but it's going to be a fractional exponent. The index will always be the denominator. The exponent will always become the numerator. Oops, should have made that a 2. So 5 to the 2/3 power is the same as the cube root of 5 squared. Looking at another one, so we've got the square root of 15 raised to the 6th power. Notice this time that that value, that 6, is outside of the radicand. It's not underneath the radical itself. That's okay, it's still an exponent. So our goal is to turn this into a fractional exponent. We're going to keep the radicand now as the base, and we have to turn this now into a fraction. The index, again, becomes the denominator, but there is no index. But by nature, this is a square root. You don't see the square, but you assume it to be there, and hence that becomes the 2. This exponent's on the outside, that becomes your numerator. Now if you left this like this, not really going to be the perfect answer. You might just lose a little bit of points, because I hope you all recognize that 6 halves is nothing more than 3. No, you don't need to tell me what 15 to the 3rd power happens to be. So I suggest you press pause, try the next two, and then continue the recording to see if you can get the next two. Alright, let's work through it and see how you did. Okay. So I'm going to take, notice that it's x and y cubed are all underneath the radical in this case. So to make sure that I understand and you understand and I understand that everything should be under the radical, I'm going to use a set of parentheses. To make sure I keep everything that was the radical, make sure I understand that that's the base. If you don't, anything that's on the outside of that set of parentheses, you're not going to recognize that it was going to be to everyone. So again, we need a fraction. The square root tells us that the denominator is a 2, and this 5 tells us our numerator is a half. If you've gotten to this point, you're in a great place. But you're not done with this problem. We can actually go a little bit further, because now we can just go back to our properties of exponents, which means we can take anybody who doesn't have an exponent, give them an exponent, and our rule when we have a parentheses and an exponent on the outside is to multiply the exponents. So we get x to the 5 halves and y to the 15 halves. That is our beautiful, fabulous answer. Alright, this next one. I'm going to follow some order of operations and try to do some simplifying first before I deal with this whole radical thing. So I'm going to take that x to the negative third, raise the power of negative 2. I'm going to change that right away to x to the sixth. Then I don't have to deal with negative exponents, I don't have to deal with fractions, and I don't have to deal with a power raised to another power. Simplified the problem quite nicely. X now is your base, 6 is your numerator, again your index is always your denominator. But again, always look to see, can I do some simplifying? Yes, 6 to the 15th can be simplified, and that can become 2 fifths. That would be nice if I could get that part right. So there's your final answer.